Next session will be with Denis Merigoux. Denis Merigoux is a PhD student at INRIA, the French National Institute for Research in Digital Science and Technology. So, hello, Denis.
Hi, Jules. Can you hear me?
Yes, we can hear you perfectly. So you study programming language, and you've participated in the creation of Catalang, an open source programming language that aims at implementing legislative text. And today you will give us feedbacks and on best practices to program the law. So the mic is yours. Good presentation.
Thank you very much. Thank you very much, Jules, and thank you for inviting me to this conference. It's quite unusual, right? Because I'm from rather academia than the industrial world. Hence, my normal ways of communicating with people is through peer review of publications. However, due to the spirit of the event today, I'm going to give you some of my more personal opinions. Not all of them will be supported by proper scientific arguments, but they're kind of informed by my limited experience that involves us talking to multiple people, especially in the administration, that are doing the difficult task of translating law into code. And I'm trying to, my field of research is actually trying to know how this can be done properly. So first, I want to introduce the subject by telling you why is it hard to turn law into code. Because it's a subject that's often overlooked by many people that just say, oh, but you just have like the tax code that defines those equations, and yeah, you simply have to compute things. You just plug in the equations and the number, and it's really easy, right? It's just a sequence of little computations where you subtract things, you multiply things, etc. However, this is a much more difficult topic than I originally foresaw when I launched myself into this area. And as an example, I'm going to show you here an example from the US tax code. And the section 121 of the US tax code basically applies when you sell a property and you're making a surplus because you sell the property for a more expensive price than what you bought it for. And then normally you have to report that surplus as income, right? And you have to pay tax on it. But there's a provision in the US tax code, the section 121, that says, okay, actually you can pay taxes, you can like deduct that extra income from your gross income, and then you're able not to pay that much taxes on your house that you bought and sold. But of course, the legislators included provisions to ensure that like this would be limited to the use case of a family that's selling their home and buying another home, right? So there's a lot of limitations. And you can see here in the text of this code that already you have like an exclusion principle, which is worded with a kind of a difficult text. And then there's a limitation, but there's actually a lot of limitations underneath. However, the global theme of this section of the US tax code and the scope, which is also the scope of my work, is to limit my studies to portions of the law that you want to translate into code, but these portions, they have to describe a decision that has no human intervention. So if the law says, okay, the judge shall decide something, then we're not going to try to code what the judge would do. The decisions should have no ambiguity, and this is a very hard topic, and we may come back on it later. And the decision should talk about quantitative data so that we have some computations that we can perform on. And the challenge here would be to translate this kind of law into code, but in a faithful manner, meaning that your code should reflect accurately what is written in the law and the spirit and the letter of the law. And this is, as you expect, a job that you as engineers have to do a lot of times, especially if you're dealing with areas of activity that are regulated by some statutes. So just to give you a guess, if you haven't done that already, of what it looks like to turn law into code, I'm going to propose to you to just change that little example, to turn that little example into law. So, okay, the way you proceed is that you just simply read the text of the law, and then you're going to write an algorithm that is going to compute the intent of the law. So here the law says how much you can exclude from your gross income when you have sold a house, for instance. So here you start to read, gross income should not include gain from the sale or exchange of property if, okay, so here we're defining the variable income exclusion with if, and if the condition is met, then we can exclude the gain from the sale or exchange, and else we can exclude 0. Okay, let's continue reading the text. During the 5-year period ending on the date of the sale or the exchange, such property has been owned and used by the taxpayers as the taxpayer's principal residence. Okay, so here you see that you have a condition. You can only deduct if you have actually owned and used the residence, the house that you've been selling. And here you can suspect there's an ambiguity, right? Because does the law says that you have to own and use it at the same time, or can it be like different periods of times, you know? And this is actually an ambiguity that we have to resolve, and that's currently this has been resolved through a regulation, which is the equivalent of the administration of the US saying, okay, if you want to interpret that law, you have to interpret it in that way. And it's also supported by case law. So, okay, so we code that by separating the periods of ownership and the period of usage. And we have to truncate them with 5-year period to respect the wording of the law. And then we can aggregate them and then compare them to the threshold of 2 years. And here you see that 2 years, there's another ambiguity, right? Because if you compare a duration of time, then 2 years is ambiguous, right? Because a year can either be 365 or 366 days. But the law says 2 years without specifying which. So here again, there are precedents and regulation that says that actually here 2 years has to be interpreted as 2 times 365 days. And you actually compare days together. Okay. But then you have one limitation that says that, okay, you can exclude the surplus from the sale or exchange, but it has to be capped at $250,000. So then you see that we were defining an income exclusion variable, but we're actually defining the income exclusion uncapped variable, and then you can cap that variable by defining another variable. So I'm going to stop here because otherwise this becomes very tedious. But you can see that on this very small excerpt of the law, we've managed to translate that into pseudocode, but that pseudocode is actually quite hard. It involves multiple disambiguations from the text of the law. And we have to define 2 variables, and this was not foreseen when we had seen the text of the law. And this operation that we've been doing over like a few minutes is performed like daily by a lot of people in the private sector, but also the public sector. And since the public sector is supposed to publish its code, which it's the one I've been investigating actually. And I've made some kind of census of all the algorithms in production within the administration that is whose specification is derived from legislative texts. As you can see, there's a lot of tax going on, income tax, housing tax, corporate tax, payroll taxes, but also all the social benefits, the unemployment benefits, the family benefits, the pensions, the grants for students, etc. All of them, they're computed by programs, and these programs, they have to respect the law that govern their behavior. And you can see two things. First, these programs, they're implemented in a wide diversity of framework or technologies, ranging from like the more legacy and obscure ones for like COBOL to more recent ones like Java, but also unusual one like SQL. It's the first time I see a 20,000 lines of code program written in SQL. That's how your payroll taxes are computed, apparently. And you can see that the lines of code can range from dozens of thousands to millions of lines of code. So it's a pretty sizable code base. And the difficulty is that you can't just write this code once and let it rot, right? Like the banking software that's mostly written in COBOL in the 60s, and that doesn't change much since. No, here the law changes each year, and each year you have to reflect the changes in the law inside your program. So you have to evolve that code base all the time, and this is very difficult, right? Because you're supposed to evolve those code bases over like decades or like centuries, because we will never know how these things are going to stop. And rewritings of those things happen very infrequently. Moreover, there are some industrial failures in the domain of translating law into code, and a very popular one in France was the Louvre failure. It was a software that computed the pay of French soldiers, and they're subject to very complicated rules about computing the bonuses. And they tried to turn that into code or in some Java things, and because of various technical and also organizational failures, this project was a catastrophic failure, so much so that some soldiers didn't have any resource for several months because of bugs in the pay computation algorithm. And like families of soldiers were literally doing hunger strikes and not having enough money to buy groceries because of that. While the military person was like overseas fighting for France, right? So it was a really bad optics. Fortunately, since it was the army, nobody demonstrated rights or nobody went to the streets because they don't have the right to do that. But the project occurred like a massive distrust into the institution, and also it cost a lot of money to fix things up. So much so that they spent hundreds of millions of euros trying to cover up the failures of that. In the US, this problem is worldwide. Actually, I'm giving French examples, but I think it happens around the world. And in the US, the latest stimulus check that was distributed with the advent of the pandemic also suffered from computation errors too, as with respect to who was eligible for the check or not. And for instance, some commercial tax software error caused 10,000 people in the US to not receive their stimulus check. Also, if you're also like a military spouse living in a base overseas, so you're not technically in the US, but you're kind of still in the US, it was like there was an error regarding to as if you were considered or not. And also they didn't receive the stimulus check. And these figures, they come from government reports and like parliamentary reports and what happened. So these are the few documented cases of complete failures that have gone wrong, and this is because of public accountability. But I suspect that in private organizations, there's a lot of such things going on that we'll never know about them because it's all shrouded in secrecy. So why? So of course there are organizational failures for these disasters, and I'm not going to come back on them, and because they're well known and studied. But there's also a more subtle technical issues on that makes translating law into code really hard to get right, and this is what we call the non-monotonic legal reasoning that exists in legal statutes. So this has been uncovered by the logic programming community in the 80s and 90s. But Sarah Lowski recently really nailed it, giving examples for the US tax code and for tax law in general. So let's take another excerpt of the US tax code, section 121, the same that we were studying previously. And this is an excerpt that says that, okay, if you're filing as a couple, then the threshold of $250,000, it should be raised to double of that, right? Because there are two people. And all of this is nice, but there is an exception to that comes with the B paragraph. And so as you can see, the reasoning and that's underlie the way that the statutes are drafted is one that has two things: a base case that also comes with a condition, but also and this base case triggers a consequence. But there can be exceptions to that base case, and before to know what consequence do you need to apply, you have to first see if exceptions apply, and if they don't apply, then you come back to the base case. But this kind of reasoning is called non-monotonic because it's not the traditional form of computer science reasoning where you examine all the branches of the if in succession and then you come to the else case. Here you have to start with the else case in some sort and then come back to the main condition. And this is adverse to encoding using nested conditionals or traditional features of programming languages. And this is the fundamental reason why it's hard to translate law into code, because you can't respect the structure of the law when you're coding it into a program. So because this is a hard problem, I'm going to try and give you some technical best practices again. So this is not like supported by the proper scientific arguments, so you can take them with a grain of salt. I don't claim to have your experience because I've only been in the domain for 2 years. But as a programming language designer and as a theoretical computer scientist, but also like trying to do applications, this is what I gathered from my experience. Okay, so one of the first things that you can do to enhance the level of assurance on your code that is supposed to follow legislative specifications is test it. And this is a very good thing. You should test things. You should write more tests. I mean, this is like a standard advice that's given to by everybody. But in practice, I've witnessed that the legal code, as I call it, is commonly under-tested. And why is that? Because in a typical legal expert system, which is like a program that's supposed to follow legislative specifications, you commonly need to have like thousands or tens of thousands of tests to actually cover the whole code base. Why is that? Because, for instance, when you compute taxes, you have to account for all the diversity of how a fiscal household can be, right? And there, for instance, in the French tax code, you have 1,500 input variables, and you need to like test all of them and test all the combinations of them. And so then there's a combinatorial of inputs of the input space that quickly explodes, and you need to write a lot of tests if you want to cover all of them. But this is fine. I mean, as software engineers, we're used to write a lot of tests. The problem is that these tests, they can't be written by programmers. They have to be written or reviewed by lawyers, because only the lawyers can interpret correctly the law. And which means that this puts a huge bottleneck on the number of tests that you can actually write and maintain, because lawyers are costly, more costly than developers, and the expertise needed to ensure that the test case, the expected result on a test case is valid or not, can be quite daunting. Moreover, whenever there's a legislative review, if you don't have a mechanism to tell you which tests which part of the code base, you need to review the entire test suite by a lawyer each year. So this is very costly. And as a result, in most organizations, the number of tests is low, very low compared to what it should be to ensure like a proper coverage of the code base. So for my do's and don'ts here, first I would say don't cut out the lawyer review. If you start to put lawyers out of the loop when validating your test and rely only on programmers because, oh, the law is self-evidently correct, the interpretations are easy, programmers can do that. This is like the recipe for subtle bugs and subtle interpretations and you not being able to comply with the law. So the lawyers are really critical in that system. Of course, I'm going to give you like a traditional software engineering advice, which is like prefer unit tests to end-to-end cases, but you have to have a unit test framework, but also you have to have the lawyers understand what is a unit test, which is sometimes difficult. And of course, sometimes it's better to have the input of the tests written by programmers, because the programmers, they're used to write test cases that ensure good coverage, right? So they're going to find the corner cases and they're going to find the extreme things. The lawyers, they're not used to do that. So the best thing is to have the programmers write the inputs, but then have the lawyer compute computes by hand the expected outputs. So then you have like a proper workflow for that. Second, technical best practice, isolate the legal code out of your application. And this is like also traditional software engineering practice, separation of concerns. You should have like one legal core with a set of functions that only perform the legal computation that ought to follow the law, and then all the other application logic should be in a separate module, right? I'm telling you that because it's frequently overlooked, and a lot of things try to mix things together, especially if you're doing like forms where the user has to input data, and then the data depend on the logic of the legal core, right? So then a lot of people mix these things together. But then the problem is that if you mix the legal code and the non-legal code, then in order to review it and to assure that it's correct, it's all bundled up with different things, and it's very difficult to assess the fiability of the legal core as a unit. And by the way, I think that this legal core should be treated as critical code, right? Because if it fails or if it doesn't, if you don't comply with the law, then the consequences can be very dire, as like I think you've heard throughout the conference, the privacy engineering conference today. So prefer to expose a function-like API for legal code that takes the inputs of your the determination of your input, like the individual characteristics, etc., and that just outputs what you want to compute. And prefer not to mix it with other things like logic for the inputs of the form input, or what boxes you have to display or not, etc. And by the way, input validation, which is part of the legal code, right? Because sometimes you're going to say, oh, I'm going to forbid the user to enter this outlandish amount of children, for instance, in their code, because we won't have to treat that. I mean, yes, okay, you can do that, but reality is completely diverse, and you will never know what actual situations you might encounter. So if you're restricting the input of the user, please be advised that it's actually a restriction, and it's a failure to comply with the law, right? Because the law is general; it has to comply with all the diversity of the situations. So then, this is something that I think has been bothering a lot of you. If you want to code up that legal core, which language or framework do you have to use? And unfortunately, there is no silver bullet, because the features that you want to do with your computations can be very, very diverse, right? Do you want to do batch computation? Do you want to do transactional computations? Do you want to display a trace of the events that have been ongoing? Do you want to give the user interactive feedback with your code, etc.? And all of these use cases, you have to use a different framework or language, right? And unfortunately, there's no like one solution that fits all. However, there are like some advice that I might give you. The first is that don't use a low-level imperative language like C or like Fortran or I don't know, SQL or anything that exposes the memory. I mean, SQL is not doesn't expose memory, but it's like don't use a low-level language. Because if you use a low-level language, you're going to mix the difficulty of the logic of the code that comes from the law with like some memory management stuff, and you don't want those to be mixed, right? I would suggest that for your legal core, you put correctness above performance. I know it sometimes it's difficult because you have huge performance requirement, but this is really my advice. I mean, treat it as like some really difficult kind of code. It's not about performance, it's really about capturing correctly the intent of the law. So I would advise you to use pure declarative, logic-oriented language, functional programming language. The higher up you go, if you don't have to handle memory, the better it is. Also, don't rush into coding before having thought the architecture of your legal core, right? Because I mean, the architecture is how are you going to encode the statute? How are you going to encode the different provisions? Because I'm saying that to you because the law is spaghetti code, and when you try to turn it into code, it's going to like turn into spaghetti code. But you have to mitigate that, and you have to really think the architecture of your code through before it turns into something that you can't manage. And of course, you're welcome to use adapted frameworks or languages that are specifically designed for that purpose. And I'm going to show some to you here. So most of the tools that handle those use cases of translating law into code, they're called rules engine. And they have diverse features. The ecosystem is not stabilized yet. So unfortunately, there's not like one strong framework I would recommend out to you. You would have to do the job of trying out all those frameworks and see which is the best suited for your needs. But this is like a non-exhaustive list, and they come from various places. Most of them are open source, but there's a couple commercial ones. For instance, the Oracle Policy Automation is like the most used commercial framework, but it's also very expensive, but also completely integrated. OpenFISCAI is some Python framework to do micro simulation. It performs reasonably well, and I think it's the most advanced of the open source tools, apart from Joules, of course, which has been around for a long time as a business rule management system, which is kind of a close parent to legal expert systems framework, right? But you have other based on JavaScript. There's a lot of things around JavaScript, right? Because it's usually embedded in web apps. But you can also venture into logic programming things with, for instance, the SWI Prolog implementation, because Prolog is quite adapted to formalizing these kind of things, because it's a high-level declarative logic programming language. Okay, so you may have encountered the idea, none of the frameworks mentioned above is really useful for me. I want something that really is tailored to my use case, and actually I'm going to go and implement my own programming language because this is the right thing to do. This is an option, and actually a lot of the frameworks some frameworks I've mentioned to you earlier they come from that idea. However, there's a big disclaimer that as a programming languages researcher, so making a programming language is hard. It's a field that has been extensively studied over 60 years. It has strong mathematical foundations, and over the course of the decades, we as a community have figured out what to do and what not to do. So if you venture out into that field and say, okay, this is just easy, I'm just going to make a little language of equations and stuff, and it's not going to be complicated, I can handle that. This is a big mistake. You will make big mistakes, and you will accumulate technical debt that will render your code base effectively unmaintainable after just a few years. I mean, I don't mean that as arrogantness. I've seen that happen, and unfortunately, you really have to kind of be an expert. I mean, you don't have to do a PhD, right? Because this is too complicated. But at least take like master level courses in things like compilation or programming languages, semantics, etc. And this will like give you the insights to if you want to create your own, not to do stupid mistakes. Like for instance, don't put null into your programming languages. So okay, a lot of languages have that, because a lot of people think it's a good idea. But as a community, the debate has been settled a long time ago. This is not a good thing to have. If you really want to have, like, if you want to express the fact that something can be or cannot be present, use what we call an option type for that. I mean, this is the proper way, because then the compiler can help you figure out where you need to insert the checks that the thing has to be null, right? Because this is the source of many mistakes. Please include user-defined functions. Don't assume that you don't need functions. You will need functions or some kind of abstraction in it, so please include them. Implementing them right is difficult, but it can be done. Include structured data, like structs or enums, for the user to be able to structure their data and not just rely on atomic data types. Inside your compiler or interpreter, use cleanly defined cascading intermediate presentations. So if this sounds Chinese to you, then I would highly recommend that you recruit a specialist in those kind of things before venturing yourself in that implementation. So this is just my little disclaimer from the programming language research, but please continue to innovate and to create new things. Just know that this is like a minefield, and that if you get the right kind of talent to help you doing that, then you'll achieve tremendous success and not carry a technical debt forever, right? Another thing in the realm of technical advice. So the unreachable gold standard will be literal programming, right, for your legal core, because this achieves the best level of documentation. And moreover, it allows you to have maintainability much easier, right? Because you know where the law changes, and since the code is right next to the law, you can change it all together with it. However, the correspondence between law and code is it's key for correctness and maintenance, but it's very difficult to do because of that encoding problem of the non-monotonic legal reasoning, which I've talked to you about earlier. So unfortunately, you can't do that in all situations, but you can mitigate that effect. So the kind of advice I would give you is to document every interpretation of the law the code makes. Like, put a lot of comments saying, okay, here the law says that. we're not sure how it interprets. We've decided that it's that's why we interpret it, but please leave it as comments to really distinguish what is like the law and what is your interpretation. Try to structure your code the same way as the law. So here I don't have like a magic solution. This is hard to do, but think the infrastructure through, like try to see, adapt it to the statute you're trying to do, etc. Include hyperlinks to official legislative sources in your documentation, so that you have that link to the official law and not something you have copy-pasted a long time ago because the law changes, right? And beware, because there's a huge syndrome of the irreplaceable hyper-expert of the code base in those kind of things. I've been a lot of places in the French administration, and everywhere they have like one guy that's been here for 40 years and then knows everything. This is good. I mean, it's good to have such experts, but the problem is that they retire. And usually when they retire, nobody is able to understand what they've written. And this can be a huge problem to your organization when this happens. So for the second part of this talk, I'm going to focus more on organizational best practices. Because it's the act of translating law into code is technical, but there's also like an organizational framework around it. Don't think that your programmers can interpret the law. Lawyers, they go to law school, and law school, it takes several years because interpreting law is hard, and you shouldn't assume that it's easy, because actually it's hard. So here are a bunch of like little advice that I would say concerning like how do you have lawyers and programmers work together. So please don't do a V-cycle when the lawyers, they take the law and they write like a docx document that of 50 pages that sort of paraphrases the law by saying it a little more precisely. This doesn't work in practice, because the lawyers, they don't know what is ambiguous and what is not ambiguous, because they're not writing the code. So the document ends up being like another version of the law but with quirks in it, and then it introduces an intermediate specification that is kind of not what you want. You want to have like direct link between the legislative source and the code. Don't separate lawyers from programmers physically and hierarchically, because they need to work together. So put them inside the same business unit or inside the same office. This is better for interactions, because interdisciplinary discussions are key, and you will manage to correctly translate law into code if you have your lawyers talk to programmers like all day, like and you have bonus points if they sit inside the same computer screens and that they actually can talk about the code or about test cases, right? And for that, pair programming actually might be a good solution. It comes from the agile methodology, but I think it applies here with the programmer writing the code and the lawyer like inspecting what is being done, asking questions, etc. I think I've kind of used it in practice, and it kind of works well. Of course, there's a legal framework for automated decision making, and I'm not a lawyer, so I'm not going to tell you how to comply with it. But I mean, just comply with the law, and I think you've heard a lot of good advice from other speakers in the conference as to that thing. For evolution and maintenance of your code base in terms of organizations, the law changes constantly, and there are new statutes being added or statutes being modified. And if your software is based on case law, you have to monitor new precedents that might change some of the interpretations that you've made. So you have to do legal monitoring. So you have to pay lawyers to, watch if the law changes. So it depends whether your software is based on statutory law or case law. But then I would strongly, this is very important, right? Because sometimes if the technology that you use is too old, or if you accumulated too much technical debt, you just say, okay, we're not going to update that anymore. We don't know how this works, and this is non-compliance. This is actually like putting you in legal risk if you do that. And this is why, because the thing changes constantly, you really have to invest in new tooling, in new ways of doing things, and at first kind of overwhelming with your current organization, right? Because if you don't do that, and if you let things like us continue as they are, then you'll have like a major crisis looming for you, because we discovered that the code hasn't been updated in 10 years, and we have to like backlog 10 years of regulations that we haven't made. And of course, as an open source enthusiast, I would highly encourage you, even though you're mostly working in private companies, to consider your legal encoding into code as an infrastructure, and then to pool it in common. Because if every company is doing their own encoding of the same law, then you're going to duplicate costs between all the companies. All the implementations will have different bugs. And then the user that might want to select like one company or the other, they will have suboptimal service, because basically not every company will have their own bugs and their own interpretation of the law. And as a user, you will experience like a not very good user experience as you try to select which company you should think. So please, I know you're not supposed to make agreements with other companies which are supposed to compete in, but please consider this as infrastructure and put it as open source, and try to build digital commons for rules as code, because this is really what we need. I know it's very tempting to try to profit from like a forged monopoly, because your encoding has been around for so long that okay, this is kind of a monopoly, so you can like charge people for accessing it. I mean, you can do that and you can profit, but as a community and as a service, your industry is not making a good point by doing that. This is not the way forward, in my opinion. Okay, and then in the last 3 minutes, I'm going to show you kind of, so here I've given you like general best practices that you should think you should apply or not. I mean, take it with a grain of salt, as I said. But I've been in my own time as a part of my research trying to come up with a solution to the problems I've mentioned here, coming from the formal methods field. So what is formal methods? It's a field at a crossroads between mathematics and computer science. It's been around for a long time. It's mostly based around the study of programming languages, proofs, and the interactions between them. And this field has industrial applications in the form of verified systems, meaning that we can, without executing the code, check that some bugs are completely absent, meaning we can prove that there are no memory bugs. The program doesn't crash. The program respects the way it's supposed to behave, etc. And it's used for critical software like train software, aviation software, rockets, nuclear power plants, etc. But we can also apply the same techniques to tax computation, or like a code that's supposed to follow the law. And our observation is that most legal expert systems are old and poorly maintained. Turning law into code requires intense programmer-lawyer interaction, as I mentioned to you earlier. And our proposal, which is joint work with like a lawyer, Liane Hutner at Paris 1, is to use the combination of pair programming, that meaning that the lawyer and the programmer should interact together, lit pair programming, which is that the code should follow the law very closely, so that you have like one line of law, one line of code. And then the code should be open source, so that other people can see how you've encoded the law into code, and can suggest improvements or other different interpretations. And for that, to enable that kind of methodology, we had to design a new programming language, because of the non-monotonic legal reasoning of the structure of the legal statutes. We couldn't choose an existing programming language, which is the same, because I would have wished I had less work to do, but I had to invest in a new programming language to enable the literal programming aspect, to really enable the code to be structured the same way as the law is. And here's a quick example of how it works. You can see that you just you take an excerpt of the law, and then you have a little annotation. So the syntax is close to natural language, but not quite, so that lawyers can actually read it and make sure that it's validated. So really quickly, the technical aspect of Catala, which is the name of the language, is that I compile the source code to other languages like C or JS or R, or like a COBOL or anything that you want, in order to provide you with ready-to-use source code libraries in case you want to like use a program that has been written in Catala inside your IT system. So in conclusion, turning law into code is difficult. The programmers and lawyers, they need better tooling, and some of it is coming, some of it I'm doing in my research, but it's really an active research topic. The best practices in a nutshell is like to follow the standard engineering best practices, but also with a few tweaks for the law. Use agile methodologies and organization mode, and really have your lawyers work together with your programmers really closely. And don't underestimate the complexity of the task, because that is really difficult. Thank you for having listened, and I think we can switch to questions. Jules, right?
Yes. Thank you very much, Denis. It was very, very interesting. So we have some questions from the chat, and one is a little bit provocative. Is the law a Turing complete language?
Okay. So I would say no, because the problem is that having a Turing complete language means that you can have programs that don't terminate, and I think that we want the law to specify things so that they terminate. So I would say no, law is not Turing complete. And actually, Catala, the language I've designed, is not Turing complete, because it makes things easier also.
All right, and I would go further about this question, because what I understand when I see your presentation is that what you've done with Catala is great, for example, for law that concerns taxes calculations or things like that. But some laws and regulations are not like that, aka GDPR, for example. It's almost a philosophy. So how do you think we could transcribe the law and its interpretation into code when the law has a blur of vagueness that we don't have, for example, in a tax regulation law, where it is if I'm like that, I have to pay this kind of taxes, and if I'm like that, I pay these taxes.
Unfortunately, that's a problem you have to ask your lawyers, right? Because they're the ones supposed to interpret the law. Of course, since the law is vague and that it's supposed to be settled by precedents, and since the law has been enacted recently, there are not precedents. So, unfortunately, you're in what the lawyers call the legal insecurity. And I mean, this is a law problem, because this is how the legal system works. So, the best we can do is to try to come up with our own interpretations, and I think the more conservative and the more in the spirit of the law they are, the better they would be suited at resisting the legal attack in court. But it's not a technical problem for me. But I agree that GDPR is very difficult to encode, because it's more about the architecture of your information systems than just like a function that takes input and produces output.
We have a question from François Xavier. And it's on the Catalan. So he asked, does one has to have basic understanding of programming language to use Catala, or is it understandable for lawyers with no coding experience, for example?
Okay, so this is a very good question, because the point of Catala is you can take a lawyer and have it like undergo a basic training of a few hours to explain, okay, what do these things mean, and why are they colored, and what is actually, what are we doing, what is the principle of computing something, right? Because they have to understand that at least. But then with these few hours of training, we've been able to have lawyers that successfully do the pair programming with a programmer and actually, okay, understand what was going on, and then, oh, here we're making an interpretation, oh, but beware of this thing and thing. So we have pretty positive reviews so far. In an article that we published, we did a case study with a class of M2 students, Master 2 students, and asking them a questionnaire about some Catala program to see if they understood or not. And we had quite encouraging results. So I think that's the use case we envision. I don't see the lawyers actually writing the code. I see the lawyers like doing pair programming with a programmer that he or she writes the code.
And another question from François Xavier. So it's a question like, would you have advices to avoid including human biases in coding the law? So it's like the same question like for algorithm. We have for algorithms like, yes, how to avoid that.
So machine learning is biased, right? Because they train on past data, and the data is biased because of all the human decisions that have been involved in the producing of the data. The thing with when you're coding something is that you can try at least to extract yourself from your biases, and for that you have to, I don't know, think rationally and apply. I mean, be aware of your biases. I mean, I'm not going to make you a course about human psychology, right? But you really have a chance as a programmer to shape your program in the way you think is the most rational, is the most like free of all biases. So please try to do that and be conscious of them. But I don't have like any specific advice because it depends on the subject and stuff. But yes, definitely. This is something you can do, which is more difficult to do with machine learning, right? Because machine learning, you're contingent on the data, and I mean, you can change the data, but I mean, this is why it's so difficult, and we have conferences of like machine learning and biases. Like it is really, really difficult problem. I think it's an easier problem to solve for traditional programs.
Okay, and to go a little bit further on this question. Who should review the code produced by a developer, for example, if you use Catalan, to be sure it's compliant with the law?
I mean, the lawyers at your organizations, right? Because the legal department at your organization is supposed to protect you from legal risk. So they're the one that have to assess what level of risk you're exposing themselves into, and by reviewing your code, they're just assessing the risk. And I mean, you can decide to take some risk, and okay, we're going to interpret the law in the code in some way, and we're taking some risk, but at least this is understood by the lawyers. And I view that just as an extension of the legal department to something which was completely obscure and arcane to them before. And it's just, okay, we understand what the code is doing, so we can assess the risk and take decisions and actually guide the implementations toward that.
Okay. And would you be in favor, for example, of like companies that try to have like to be ISO something? Do you think it could be a good thing to have like labels like that for a language or the implementation of a language?
So in the formal methods community, we don't have the ISO label. We have what we call the proofs of language correctness, so which I've done, by the way. It's in the latest paper, so we don't have the ISO stamp, but we can guarantee mathematically that, for instance, the language is coherent, meaning that the typing is coherent with the execution, and that the compilation preserves the semantic. So when you translate to another programming language, you have the same behavior as you would expect in the source language. So we have all of that. And I guess that's, I think some languages, C has the ISO standard, right? But then, you know, for these procedures, the cost is to make the paperwork for the standard, right? And to undergo a very long process with long steps, etc. Maybe in the future, if Catalan works, we'll do it for that right now. But technically, what matters really is the proofs and the formal methods aspect of it, which is like already done.
And maybe a last question. You said that you were in favor of open source projects for this kind of languages or implementation of this low language. So could you just detail a little bit more why you think open source project for that is very important?
I think it's important because, as I said in my slide about like building digital commons, if you as a company try to say, oh, okay, I'm going to translate that into code and then I'm going to profit from it because nobody else has done it. And then like a competitor appears. And then you have like 3 companies that are doing the same thing and that have their own closed source programs doing the same thing. But then each of them has different bugs and different features. So you as a customer, you have to select between like neither of all the offers that you have are optimal, right? Because they're all made with limited resources, and it's just make more sense that these programs are doing the same thing. So and it's not as if in the ideally one program should not be better at encoding the load than another, right? They just should encode it correctly. So I think competition doesn't concern the encoding of the law, right? So it makes sense to bundle it, to put it together as an infrastructure. But I mean, I'm not the CEO of a company, so I can't make the decision, right? But it's kind of a perspective that you have to think. I don't think it's a good idea for you as a business decision to say, okay, we're going to build our business value by having a private encoding of the law and keeping it secret, etc. I don't think it's a good thing.
Okay. We hear your point. Thank you very much, Denis. And I wish you a pleasant day. And don't hesitate to go in the chat if you want to answer other questions. Thank you very much.
Thank you. Bye.